Hello everyone, welcome to the topic Relations and Functions. Here we discuss composition of functions, FOG, GOF and inverse of a function. Let f from r minus set minus 4 by 3 to r be a function defined as f of x is equal to 4x upon 3x plus 4. Find the inverse map. Let us see what is the domain given to us. R minus a set with one element. What is being subtracted from set of real numbers? Only one element, that is minus 4 by 3 to be deleted from the domain. Delete minus 4 by 3. Minus 4 by 3 is approximately minus 1 point something. This one number is deleted. That is a domain. And the codomain is complete R. And rule given is f of x is equal to 4x upon 3x plus 4. Now we need to find the inverse. To find the inverse, we need to get a g from the codomain to domain in such a way that GOF is identity function and FOG is identity function. How can we have such a g? Let's go ahead. Let there be a y in the codomain. And if possible, let that y be obtained by this calculation 4x upon 3x plus 4 for some x of the domain. From the domain, some x image is this y. So which is that x? To get back to that x, there must be some rule. That rule is what going to be the inverse. How to get that rule? We'll go to this equation and solve for x. Cross multiply. 3yx plus 4y equal to 4x. We are solving for x. We want that x. So I take the x terms, like terms on one side. And 4 minus 3x is 3y is the bracket of coefficient. So x is equal to 4y upon 4 minus 3y. That means for any y, we can get back to its x through this rule. Now let's take this rule as the g function. Take this as g function defined from codomain to domain. That doesn't mean that this has become the inverse. We need to cross check. We need to prove that this g satisfies these two conditions. So using this g, let us calculate GOF and FOG. Let's see whether they come identity function. GOF of x is equal to g of f of x according to the composition O. G of f of x. What is f of x? F of x is this rule. So let me replace this rule in place of fx. 4x upon 3x plus 4. Now g of this expression need to be calculated. What does the g say? G says g of any element is 4 times the element upon 4 minus 3 into that element. So this element is going to be used in the g rule. So the step goes this way. 4 times the element upon 4 minus 3 into the element. 4 times y upon 4 minus 3 into y. In place of y, I use this big expression so that I get g of this expression. Now let's see how to calculate it. The numerator is 16x upon 3x plus 4. Here we need to take an LCM. Step will go this way. LCM 12x plus 16 minus 12x equal to the numerator 16x. The denominators, both denominators 3x plus 4, 3x plus 4. So it is 16x upon 16, 12x and minus 12x, 0. It's equal to x. What has happened? GOF of x is equal to x itself, which means GOF is an identity function. GOF is identity function. Let's check the other one, FOG. FOG of y is f of g of y. Replace the g of y here, 4y upon 4 minus 3y. So f of this big expression we need to calculate. Now, what does the f say? F says 4 times the element upon 3 times the element plus 4. This is the element we have to place here. So the step will look like this. 4 times the element. Element is this whole thing is the element. 4 times the element upon 3 times that element plus 4. Now simplify this. Again, 16y upon 4 minus 3y upon, here taking LCM, the step comes this way. Again, 12y minus 12y is 0, so 16y upon 16 is y. So, FOG of y came out to be y itself. FOG of y is equal to y. That means FOG is an identity function. So, this g that we took is exactly fitting with this definition. So, this g is making the GYF and FOG identity functions. This g. Hence, this g that we had already got earlier is the inverse of fx. Hence, f inverse of y is equal to 4y upon 4 minus 3y. This is the inverse.